Hello, everybody. Welcome to lesson number 12, where we are going to be looking at adding and subtracting polynomials. So, polynomial, big word, but I promise it's not that bad to work with. Our definition here at the top of our page. What is a polynomial? So, a polynomial is an expression made of these things. It is a variable and a number and an operation, addition or subtraction. Here's an example of a polynomial. So this expression, 3x plus 4, that whole thing is called a polynomial. Here's another one. 5x squared, take away 2x plus 7. That whole thing is a polynomial. This one here, the 8 take away 3x, that is a polynomial. They all have a variable, those letters. They all have a number, the constants, and they all have an operation, addition or subtraction. So under here, there's a little task for us to complete. Label the parts of this polynomial. Okay, we have 10 plus 4x. So here we know this is a number. Our number at the top in the brackets, as we see, is called a constant. Now it wants us to find the variable. Which is the variable? X. That is our variable. Now, in front of our x variable, we also have a number, 4. That is our coefficient number. And our operation. Let's see here. That is our operation, and it is addition. What are like terms? Like terms have the same variable and same exponent. The variable part must be exactly the same. Example of like terms, 3x and 7x. Notice how the numbers are different, but they have the exact same variable, which is the x, and that x has the exact same exponent, which is 1. We can't see it, but we know it's there. 5x squared and negative 2x squared. Those are like terms because they both have x squared exactly the same. What is another example of like terms? So it's asking us to just come up with something on our own. So let's think. Off the top of my head, 6x. What will match that? Anything, any coefficient plus x will be a like term. Let's go, we'll make it interesting. We'll use a negative. Let's go negative 3x. This has an x. This has an x. Those are the same, therefore they're like terms. We can do another one. We can do one with an exponent. Let's go 9x squared. So then to make a like term, we need to choose any number and then just add the exact same variable, so the exact same x squared, and it will be a like term. So then we will add 2x squared. We have x squared and x squared. They are exactly the same. They are like terms. Now under here, it's showing us these examples. These sets are not like terms. Why are these not like terms? As you can see here, we have a 3x and a 3x squared. Why are those not like terms? They have different variables. One is an x, one is an x squared. They're not matching, they're not the same, they are not like terms. Our answer will be the variable are different. The exponents are different. That's why they are not like terms. And it gave us some other examples. 4x and 4y, those are not like terms. One is an x, one is a y, not the same. 5 and 5x, not the same, not like terms because one has an x, one has no x. Adding polynomials. When adding polynomials, the first step is always going to be combining the like terms. So let's look at these examples here. Now, bear with me. I'm going to have to do some reading through of this. Example 1, 3x plus 5x is what? So we're going to solve for that answer. We have to add those coefficients, those numbers in front of the x, and keep the variable. So you're going to add the 3 plus 5 is 8. And then you're keeping the x throughout. Solve for the expression in the simplest form. This type of question has multiple steps. Multiple steps? We love multiple steps. So first, step 1, we have to group the like terms. If you notice, like terms, what has the same variables? So we have to put all the x's together and then everything that doesn't have an x together. We will switch this expression around and organize it. We're going to put the x's on this side and then the numbers that don't have an x on this side. We grouped all the like terms together. After they're together, after the like terms are grouped together, you can add the coefficients, just like in example 1, and add the polynomials to solve for the answer. So that brings us, I'm just going to rewrite this. This is what we are working with. So we have 4x plus 6x. I'm just going to go off to the side here. That will give us 10x. And then we have a positive 3, take away 2, and that will give us 1. If we put that together, we will have 10x plus 1. That is our answer. And just a note, always organize before solving. Now remember, we're not solving for one single number. We're solving for the simplest form of the expression. This is our answer. It's an expression, but that's our answer. And now subtracting polynomials. When subtracting polynomials, there's an important rule. Subtracting polynomial means distributing the negative. So we are going to be looking at that example, and we are going to be taking that negative and spreading it throughout our bracket. So we have 6x plus 4, take away 2x plus 3. This is a polynomial, and this is a polynomial. And we are going to subtract them. The first step is to distribute the negative, because the reason being we need to get rid of our brackets. That brings us back to BEDMAS. Brackets, we need to do that first. Let's get rid of that. So we know there's an invisible positive 1 on the outside of that. If we bring that 1 and we multiply our positive 1 by those two terms, they become 6x plus 4. Now we know this is technically a negative 1. So negative 1 times 2x will give us a negative 2x. And then we're going to bring that negative 1 over to our positive 3. So negative 1 times 3 will give us a negative 3. We distributed the negative. We have no more brackets. Now we can combine our like terms and solve. So this is what we're working with. Where are our like terms? We're looking for the same variables. Let's organize. 6x, what is the other term that has an x? It's our negative 2. Take away 2x. Put those together. And then we're left with our 4 and our negative 3 that have no variables. So we have now combined all our like terms. We can solve this by simply following the operations. 6 take away 2 is 4. Keep our x. And then 4 take away 3 is 1. So our answer is 4x plus 1. And then I have a note here. I said, isn't this fun? We love organizing. So let's practice. Question number 1. We're going to simplify that expression and that problem, and we're going to show all of our steps. First thing we have to do, we're familiar now, we have to combine our like terms and then solve. Organize first and then solve. So we have 5x. What else has an x? Our 3. Let's put those together. And then we have our 2 and our 7 that have no x's. We're going to put those together. From here, we can now solve for our expression. These both have the variables. We can add them. 5 plus 3 is 8, keeping our x. And then positive 2 take away 7 gives us a negative 5. So if I just show this like this. Okay. And there is our answer. Our answer is 8x take away 5. Now, here is our subtraction of polynomials. When we see a subtraction of polynomials, we have to automatically think, distribute the negative, get rid of the brackets. So remember, we have a 1 here and a 1 here. Positive 1 is on the outside of that first bracket. Negative 1 is outside of that second bracket. So if we do that, and we will take the numbers out of our brackets. That'll give us 7x, take away 5. Now, negative 1 times 3x will give us a negative 3x. Negative 1 times 2 will give us a negative 2. Now that we distributed our negative, let's combine our like terms. Let's put all our x's together. And let's put our numbers that don't have x's together. Now that we combined our like terms, we can solve. 7 take away 3 is 4. Keep our x. Negative 5 take away 2 is 7. Negative 7. So our answer is 4x take away 7. Great job, everybody. So last one here. This one has everything. It has our exponents. It has our polynomials. It has like terms. So we are going to take it slow. We are going to stay organized. And we are going to simplify this problem. The first thing we want to do is group all of our like terms. Remember, our like terms have exactly the same matching variables. Let's start with this one. 2x squared is our first term. Let's put all of our x squared numbers together. So what else has an x squared? The 5. 5x squared. Is there anything else that has an x squared? No. Let's move to our x then. We have a 4x. Let's put all of our numbers that have x together. 4x, and we have a negative 6x, and then nothing else. Now that leaves us with our negative 3 and 8. Those don't have any variables, so we'll keep them together. Next thing we're going to do is solve these. So I'm just going to draw it out like this, just to keep track of what we're doing here. 2 plus 5 is 7. So that gives us a 7x squared. 4 take away 6 is a negative 2. And we're keeping our variable. And then a negative 3 plus 8, that gives us a positive 5. So our answer, if we put it together in an expression, will be 7x squared take away 2x plus 5. And that's it. That's how we simplified it. Some notes that I want to just summarize our lesson with. Only combine like terms. So we are not going to combine the 7x squared and 2x. We're not going to subtract those because the variables are different. We keep them separate. We add or subtract coefficients. So we add and subtract the big numbers attached to the letter variables. The coefficients are what we are adding and subtracting. When subtracting, we have to distribute the negative. Meaning we have to move that negative 1 into the brackets, distribute that negative 1 so that we get rid of our bracket. And our last one is always organize before solving. Staying organized is key. If we don't stay organized, then we will get the wrong answers. But that brings us to the end of our lesson. And now you can go work on your student matching handout, and I will see you next lesson.